Hello everyone, my name is Nashif. I'm a principal engineer at Intel. Sorry for not being able to attend in person. I was hoping to meet many of you and participate in many of the sessions and discussions happening this week around Zephyr. So hopefully next time. But for now, in this short presentation, I will be talking about the power of consistency and how consistency is important for an open source software project like Zephyr. I will be also sharing with you why this is important for us at Intel, given the wide range of products Intel has, and how this helps us become more efficient delivering some of these products. So I will start by raising the question, think Intel, what comes to your mind? Because you are not able to answer me, I will highlight some of the possible answers here. Probably you have thought about x86, laptops, running Windows or Linux, server products, and so on. Now, if I ask you to think RTOS, most likely Intel will not be there. And that's for an obvious reason, is that you don't go and buy an Intel laptop to run on RTOS. Most likely you will run a powerful operating system like Windows or Linux to run productivity software, to play games, to do video conferencing, etc., etc. And that doesn't mean that Intel is not involved with real-time operating systems. Intel actually is a major user of real-time operating systems, and RTOSes are all over the place at Intel. Not only RTOSes, firmware environments in general. And that comes due to the fact that we have a wide range of products that requires firmware to run them. So going all the way from the CPUs, most of you are familiar with, running the laptops you have probably in front of you right now. There are accelerators, there are boards and systems, connectivity products, Wi-Fi, Bluetooth, and so on. And there's also memory and storage products, and all of these products obviously require firmware, and depending on the use case and the complexity of the product, this could be a firmware running an RTOS. In some cases, you have multiple firmwares running in a single product, in a single SoC, to support all of the use cases such a product needs to deliver. So looking at that, and given where we are today, you realize that what used to be hardware in the past is actually now mostly done in firmware. So that's why if you look at the wide range of products and the multiple use cases you need to support in each product, you will end up having thousands of microcontroller usages. And most of these microcontrollers would be running ARM, ARC, Intel, RISC-V, you name it. Any ISA out there most likely will be available in one product or another. Many things that used to be hard or process dependent now use microcontrollers. This is the point, and microcontrollers need firmware applications to run them. That the simple ones would be happy with a bare metal application, but there are complex applications that would require a full RTOS environment. And this full RTOS environment most likely would be running on one of the many popular architectures mentioned above. So basically, to illustrate that and make it simple, if you look at an Intel platform, let's say a laptop running Windows or Linux, you can also run on RTOS if you need to, either directly or on top of a hypervisor, would require a few IPs and a few applications, processor application to deliver what the system promises in terms of features. So you would require like a sensing firmware, a sensing IP in this case, a dedicated hardware for sensing, same thing for security, for audio. An embedded controller, needed to boot up the system and manage power sequencing, manageability. If you are like an enterprise product, you want to be able to manage systems remotely, apply software updates, and do remote operations, remote management on such systems. And the thing is, this is not done in one single IP. These are multiple IPs, most likely, and depending on the use case, they would be running different on top of different ISAs, x86, ARC, Extensa, ARM, RISC-V, you name it. And as we have seen, these are all different use cases. So this type of requirement, this type of reality requires, when the more firmwares you add, the more complex the system becomes, and developing all of these firmware applications it's a major effort that has to be done for each generation of these platforms. So basically, the multiple use cases on different hardware ISAs require a new approach, and that's basically a common and a portable OS with hardware agnostic and consistent interfaces and ecosystem. So let's look further at where we are. This is a typical Intel platform, very complex one in terms of the feature it provides, but it doesn't have to be that complex to require consistency in this case, and this common and portable OS. We have seen that in Zephyr in the past. Zephyr actually was launched 7 years ago with an Intel platform that has a limited complexity, but was complex enough to require us to think about how this should be done in the most consistent or most efficient way possible. So Curie, for example, was, besides being the first platform supported, one of the first platforms supported in Zephyr, was a multi-core platform. It has 3 cores. It had 3 cores, x86 for the application core, a sensing subsystem based on ARC, and a Bluetooth controller running on ARM. A lot of the IPs and a lot of the peripherals were shared across the cores, and that led us to set a few requirements to be able to support this type of hardware. Consistency in this case is not only about APIs and how you write code or how you design your subsystems and services. It goes all the way to how you contribute things. So basically, we also very early on established best practices and put a lot of guidelines that most of which came from Linux actually. So things like the coding style, coding guidelines, how you contribute and even all the way to how you write your commit messages. So if you compare commit messages that were submitted or merged recently with commit messages from the early days of the project, you see that we have been following the same principles, the same guidelines, the same rules all along, and that helps a lot. When looking back and trying to understand why certain things came to be. So going back to the example of Intel platforms, I think you can see why it is important to have consistency in a software project like Zephyr. So, taking sensing for example, it's running on x86 on IA. Audio is running on Extensa. Manageability on some Intel platforms is running on ARM. It can be also running on x86. EC, the embedded controller, is running on either ARM or RISC-V. Security might be running on ARC or x86. And this is something that the platforms evolves all the time and changes happen all the time, and it's very important for us to actually be able to mix and match or switch or share some or reuse some of the features when these products evolve. So assume, for example, if at some point we decide to move the sensing IP from IA to something else, we don't want to go and rewrite the application or the firmware and start from scratch. We want to jump to the next ISA, whatever it is, and be able to use the same code that was written originally. And that's one key factor in basically selecting one single firmware OS for this type of IPs. Also think about IP sharing and peripheral sharing. Many of these firmwares would actually use or support the same IPs, coming usually from third party, but sometimes they are original designs from Intel. And it is very important that you would be talking to these IPs using exactly the same IP, the same APIs. It is important to be able to reuse the code that you have written for one solution on something else. So that's basically can only be done if your interfaces are consistent, if you implement and abstract as much as possible in your software development. And it can't work if you go and implement everything for a specific hardware platform. So I hope all of this now is starting to make sense and why consistency is important. I mean, think about the basic stuff that you do on a daily basis when you use Zephyr. When you build, you just run wist build, platform name. You don't care about the tool chain. You don't care about the setup, the build system, etc. Everything is done for you. Never mind which platform you are building for. It is exactly the same way. Same thing when you flash, when you debug, things are abstracted. You don't have to, in most cases at least, you don't have to do additional steps when you are switching between platforms of different hardware architectures. So that's a key point, and it is one of the major advantages of using Zephyr when compared with other RTOS environments. So having said all of that, I think the summary of all of this is going to be that consistency is really the difference between failure and success, especially when it comes to open source project and our projects in particular. Consistency establishes reputation. That's basically how people learn to appreciate the project and the way things are done. It creates accountability as well, helps maintaining the message, and above all makes the Zephyr project relevant, because as an open source project, it's very important that we stay relevant. When people look at the code, when people look at what we are doing, there has to be a story there. I mean, it can't be random contributions from different vendors from the community with the goal of making different hardware platforms and different features work together in any way possible. There has to be a system, there has to be a structure, and this structure is only achievable if you set rules very early on to establish consistency for how things are done. So during this conference or developer summit, there will be a few talks going into this topic. It is definitely something that users and developers of Zephyr appreciate and value, and I think this is something that we need to continue to maintain. Probably we are not perfect in many areas or some areas, but at least based on where we are right now, we are on the right path to get there. People appreciate consistency, and it helps the project getting more adoption and more users, and that's basically the message here. Thank you very much, and see you next conference. Bye bye.